Digital Physics 4 is about sampling. So we've talked about images, now we're going on to sound. And to convert an analog audio signal to a digital one, the process is called sampling, if you like, analog to digital conversion. Here's my original analog signal. And what we do is we've overlaid a grid onto it, and there are 16 levels on this grid. Why 16 levels? Because then each level can be represented by a 4-bit code. Remember that the number of possibilities is 2 to the bit depth, and 2 to the 4 is 16. And then what we do is many times a second, we ask a question: what level is the signal closest to? And that's the little black dots on the grid, and they are your samples. Now, these can be stored onto a computer, and then when you want to listen to what you've recorded, the computer can change it back into an analog signal. Will we get a faithful reproduction? Will we get what we started with? And that depends. In other words, how accurate are our samples? And that will depend on two things. It will depend on the sampling rate, and it will depend on the bit depth. The sampling rate is how many samples we take every second. Very often that's measured in kilohertz. And then the bit depth is how many bits we assign to each sample. Imagine this is the highest frequency component in a signal. So how many samples do we need to take for every cycle? If I want to reproduce this wave, how many samples per cycle do I need? Now, looking here, I've taken more than enough. Now, there wouldn't necessarily be any problems, but it would be a waste of memory. I don't need that many samples, which is 1, 2, 3, 4 per cycle. I don't need. Here, I haven't taken enough. And because I haven't taken enough, when this is reconstructed, if you look at the grey line, what we're going to end up with is something called an alias, which is a low frequency component that shouldn't be there. Very often it sounds like a hum, an annoying hum. We haven't taken enough samples. What's the minimum number of samples we need? Well, it's this diagram here, and it's 2 samples per cycle. With 2 samples per cycle, we can reconstruct the highest frequency, and that has a name. It's called the Nyquist rate. The Nyquist rate is the minimum sampling rate, and it should be equal to double the highest frequency component in the signal, because it's 2 samples per cycle. For example, high quality audio is sampled at about 44 kilohertz. Why? Because the highest frequency that humans can hear is about 20 kilohertz, which is about half that. Bit depth. Now, remember that the number of possibilities is 2 to the b. So in this case, the number of possibilities is the number of levels. If we had 4 bits per sample, then there were 16 levels. The more levels there are, then the closer our samples will be to a possible level, so they will be more accurate. However, if you're dealing with a signal that includes a noise component, if the signal has picked up noise, then there is a limit to how many bits you should use. There is a maximum number of bits that you should use. Okay? For example, this signal here clearly has a noise component, this high frequency component. Okay? And we can actually avoid sampling the noise. And the trick is, what we do is we have it so that the distance between the levels is just greater than the amplitude of the noise, the peak-to-peak amplitude of the noise. Mathematically, if Vs is the amplitude of the signal and Vn is the amplitude of the noise, then Vs over Vn, to avoid sampling noise. Now, Vs over Vn is actually called your signal-to-noise ratio. And your signal to noise ratio should be greater than or equal to 2 to the b, where b is the bit depth. So to avoid sampling noise, Vs over Vn should be greater than or equal to 2 to the b. If you're good at maths, then this can be expressed log to the base 2, etc. To be honest, I prefer the equation on the left. It's called the Shannon-Hartley theorem. Here's a question for you to have a go at. Pause the video, have a go, and I'll show you the answer in 5 seconds. 4, 3, 2, 1. And there you go. Okay, have a go at my 20 questions. Jolly good revision.